Okay, Unit 4, we're still working with triangles, but we're talking about special segments that can be formed within the triangle. So I'm going to talk about these 4 words for a minute, just to explain what that means, what they mean. So the first one we're going to talk about is the median. When we hear the word median, typically we think of the word middle. And so that's what we do. We first find the midpoint here, so where I highlighted in purple, and we would find that midpoint, and then we connect it to the opposite vertex. And what happens is it bisects each side so that you know that each side is cut into 2 equal parts. Okay, so that's what a median does. Now, the magic number with triangles is 3, so every triangle is going to have 3 medians. And where they come together is what's called the point of concurrency, and in this case, it's called the centroid. The centroid splits each median into 2 parts. The big part is 2/3 the length, the small part is 1/3. So as an example, let's say that this line here in green has a length of 15. I know that the long part would then be 10 because 2/3 of 15 is 10, and the small part would be 5, 1/3. So that's the basics of a median. Just know that each side is cut in half. The next one we're going to talk about is an altitude. Altitude is just a fancy word for height. And so if you are measuring the height of something, it has to be perpendicular to what you're comparing it to. And so each altitude has to be perpendicular to the base. And when we use the word perpendicular, we know that we're talking about right angles. When all your altitudes come together, they meet at the point there that you see in the triangle, and that is called the orthocenter. The next one is the perpendicular bisector. So we start out the perpendicular bisector very similar to how we did the median. We first find the midpoint, but instead of connecting it to the opposite vertex, we want it to be perpendicular to the base, so we draw it straight up and create that right angle. We know that it does cut those pieces in half, and then when you have all your perpendicular perpendicular bisectors coming together, their point of concurrency, so where they all meet up here, is called the circumcenter. The one extra thing that you need to know here is, and I'm going to highlight in blue, the distance from the circumcenter to each vertex, those are all the same. Last one is the angle bisector. It pretty much is what it says it is. We're cutting each angle in half. So we would cut each angle into 2 equal parts and bisect them. And then this part in yellow that I'm going to highlight, the distance from where all the angle bisectors meet up, called the end center, where from the end center to the edge of the triangle, those are all the same. So those are just some little information that you need to know. Now, in your notebook, I went ahead and put a page for acute triangles. I put one for obtuse triangles, and I would put one for all the right triangles, just so you could see all the different options here. And if you look here, altitude, when all the altitudes meet up, they're meeting way out here down. You can't even see it in the picture. The circumcenter here in an obtuse triangle is outside. So I just wanted you to have an opportunity